Good morning, students. So our topic for this week is all about set operations. There are operations involving sets, and this includes difference of two sets, intersection of the sets, and the union of the sets. Now let's define the difference of two sets. It is the set of elements of A that are not in B, and was denoted by A minus B. For example, what is the difference between A and B? Suppose we have the elements of A, which is 0, 2, 4, 6, and 8. And the elements of B is 6, 7, 8, 9, and 10. Now we're going to cross out the common elements. So the common elements are the 6, 8, and now what's left in set A is 0, 2, and 4. Again, the definition of the difference of two sets, it is the set of elements of A that are not in B. So the elements of A that are not in B are 0, 2, and 4. So we have the difference between A and B is 0, 2, and 4. Example number 2. Give the difference between B and A. So we have the elements of A, which is E, I, G, H, and T. And the elements of B is H, E, A, and T. Now we're going to cross out the common elements. So the common elements are letter E, letter H, and letter T. Now we're going to give the elements of B which is not in A. So we have letter A. Now B minus A is equal to the element of A. Next, the union of the sets. It is the combined set of elements of A and B, and it was denoted by A union of B. Example number 1. We have the elements of A 0, 2, 4, 6, and 8. And the elements of B 6, 7, 8, 9, and 10. Now we're going to combine all the elements. But remember, 6, 8, are the elements which are present in both sets, and it will appear only once. So we have A union of B is equal to 0, 2, 4, 6, 7, 8, 9, and 10. Example number 2. We have the elements of A 1, 2, 3, 4, 5, and 6. And the elements of B 4, 5, 6, 7, 8, and 9. We're going to use the Venn diagram. So we have two circles. This is for the elements of A, and this is for the elements of B. And the center are the common elements. Now we're going to identify first the common elements. So we have 4, 5, and 6. Now we're going to write the common elements at the center. So we have 4, 5, and 6. And elements in A, which is 1, 2, and 3, belongs to elements of A. And elements of 7, 8, and 9 belongs to B. Now we're going to combine all the elements. So we have the union of A and B is equal to 1, 2, 3, 4, 5, 6, 7, 8, and 9. Next, the intersections of the sets. It is the set of elements of A that are also present in B. And it was denoted by A intersection of B. Example number 1. What is the intersection of sets A and B? Suppose we have the elements of A, which is 1, 2, 3, 4, 5, 6, 7, and 8. And the elements of B is 3, 4, 5, 6, 7, 8, 9, 10, 11. Now we're going to identify the common elements. The common elements between A and B are 3, 4, 5, 6, 7, and 8. So we have here the intersection of A and B is equal to 3, 4, 5, 6, 7, and 8. Example number 2. We have the elements of A, which is 1, 2, 3, 4, 5, and 6. And the elements of B is 4, 5, 6, 7, 8, and 9. So we're going to use the Venn diagram. So this is for the elements of A, for the elements of B, and the common elements. So the common elements are 4, 5, and 6. And the elements for A is 1, 2, and 3. And for the elements of B, 7, 8, and 9. Therefore, the intersection of A and B is the common elements of both sets. So we have 4, 5, and 6. So we can use the Venn diagram to solve word problems involving operations of sets. For example, we're going to do the math exercises. The diagram below shows the data gathered by a school about the upcoming grade 11 students and their preferred courses. Try to interpret the data by answering the questions that follows. So, the illustration shows the data of the upcoming grade 11 students with their preferred courses. So we have 3 courses, the UMS, the ABM, and the STEM. So we have for the UMS, we have 5, 40, 11, and 30. And that gives a total of 86 students who enrolled at UMS. Next we have for the STEM, 30, 8, 11, and 28. And that gives the total of 77 who enrolled STEM. Next we have ABM, 40, 7, 11, 28. and that gives the total of 86 students who enrolled in ABM. And neither of the three courses, there are 10 students who never choose 3 of the courses. Now, question number 1. How many students prefer ABM but not STEM? So as you can see at the diagram, so the students or the number of students who enrolled at ABM are 40, 7, 11, and 28. However, 11 and 28 are the students who also enrolled in STEM. So we're not going to include 11 and 28. We're just only combine 40 and 7. So 40 plus 7, that gives the total of 47 students who prefer ABM but not STEM. Next, number 2. How many students prefer UMS and STEM? So as you can see at the data, the number of students who enrolled in UMS and in STEM. So we're going to get the common between the two. The students or the number of students who prefer both UMS and the STEM are 11 and 30. So we're going to write 11 plus 30. So we have 41. There are 41 students who prefer UMS and STEM. And this concept being used is the intersection of the sets. Next, number 3. How many students prefer ABM, UMS, or both? So we're going to use the concept of the union of the sets. So we're going to combine all the cardinality of the UMS and the ABM. So we have 40 plus 11 plus 30 plus 28 plus 5 plus 30. That gives the total of 121 students who prefer ABM, UMS, or both. Number 4. How many students do not prefer any of the 3 courses? So as you can see, there are 10 students who do not prefer any of the 3 courses. Number 5. How many students were surveyed by the school? So we're going to use the union of all the sets, or we're going to use the concept of the universal set. So we're going to add all the data. So we have 5 plus 40 plus 11 plus 30 plus 28 plus 7 plus 8 and plus 10. So that gives a total of 139 students were surveyed by the school. Exercise number 2. In a survey of university students, 64 had taken mathematics, 94 had taken chemistry course, 58 had taken physics course, 28 had taken mathematics and physics, 26 had taken mathematics and chemistry, 22 had taken chemistry and physics, and 14 had taken all the 3 courses. Find how many had taken 1 course only. So, we're going to follow the steps. Step 1. Identify what are the givens in the problem. So, the givens in the problem are the following. There are 64 students who had taken mathematics course. There are 94 students who had taken chemistry course. There are 58 students who had taken physics course. There are 28 students who had taken mathematics and physics. There are 26 students who had taken mathematics and chemistry. And there are 22 students who had taken chemistry and physics. And there are 14 students who had taken the 3 courses. Step 2. Identify what is asked. The number of students who had taken only 1 course. Next, step 3. Make a Venn diagram and label each circle. So, since we have 3 courses, so we're going to have or to use 3 circles to illustrate the problem and label each circle. So, we have M for mathematics. We have C for chemistry. We have P for physics. Next, step number 4. Put the number of the students who had taken the 3 courses at the center. So, there are 14 students who had taken the 3 courses. So, we're going to write 14 students at the center of the 3 circles. Next, write the number of students who took both math and chemistry between the circle of M and C. So there are 26 students who had taken mathematics and chemistry course. However, there are already 14 students. Therefore, we're going to subtract 14 from 26, and that gives to a total of 12 students. Next, write the number of students who took both math and physics between the circle of M and P. There are 28 students who had taken mathematics and physics course. However, there are already 14 students. Therefore, 28 minus 14, and that is 14. So you're going to write 14 between M and P. Step 7. Write the number of students who took both chemistry and physics between the circle of C and P. There are 22 students who had taken mathematics and physics course. However, there are already 14 students. Therefore, 22 minus 14, and that is 8. So you're going to write 8 between C and P. Step number 8. Write the number of students who took mathematics alone at the circle of M. There are 64 students who had taken mathematics. So you're going to add 12, 14, and 14. So that is 40. Now, you're going to subtract 64 minus 40, and that is 24. So there are 24 students who took mathematics alone, and you're going to write that one at the circle of M. Step number 9. Write the number of students who took chemistry alone at the circle of C. There are 94 students who had taken chemistry. You're going to add 12, 14, and 8. So that is 34. Next, 94 minus 34, that is 60. So there are 60 students who took chemistry alone. And you're going to write 60 at the circle of C. Number 9 or number 10 or step number 10. Write the number of students who took physics alone at the circle of P. So there are 58 students who had taken physics. So you're going to add 14 plus 14 plus 8, and that is 36. Now, 58 minus 36, and that is 22. So there are 22 students who took physics alone, and you're going to write 22 at the circle of P. Now, step number 11. Determine the number of students who taken only one course. So we're going to identify the number of students who only took one course. So for mathematics, there are 24. For chemistry, there are 60. For physics, there are 22 students. Now 40 plus 60 plus 22, and that is 106. So there are 106 students who take or who took only one course. And that's all for this week, and God bless.